In just a moment, I'm going to give you some exercises to work. It's very important that you work the exercises and check your answers. The rest of the tape depends upon you being able to do the conversions perfectly. The first exercise, convert to decimals. So convert from scientific notation to decimal notation. 7 61/100 times 10 to the 5th. 1 200 times 10 to the -3. 9 312 thousandths times 10 squared. The second exercise involves converting to scientific notation. So here you convert from decimal notation to scientific notation. 780,000 to scientific notation. 131 10,000,000ths to scientific notation, or it's 0.0000131. 920 to scientific notation. Now this one is not decimal nor scientific notation, it's kind of a hybrid, but I want you to convert it to pure scientific notation. 37.8 times 10 to the -5, converted to pure scientific notation. Now copy down all these problems, and once you have the problems copied, stop the tape, work the problems, and then restart the tape to check your answers. If you disagree with any of the answers, be sure to check with an instructor or a tutor. Remember, if you have an answer different than mine, you could be wrong or I could be wrong, but in either case, you need to find out. Now we get to the real fun part of today's lesson. That is evaluating very large or very small numbers. Let's evaluate 2,700,000 times 120 million. So that's 27 with 1, 2, 3, 4, 5 zeros times 1, 2 with 1, 2, 3, 4, 5, 6, 7 zeros. So we want to evaluate that. The first thing we need to do is to convert to scientific notation. Let's write those numbers in scientific notation. Well, I can write 2.2700000 as 2.7 times 10 to the 6th. Because notice it's a large number, so my exponent will be positive. And in order to get the exponent of the decimal between the 2 and the 7, I need to move it 1, 2, 3, 4, 5, 6 places. This is also a very large number. In order to get it in scientific notation, I need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 places. Since it's a large number, the exponent will be positive. Now it's very easy to do. I can regroup my decimal part and my powers to get 2.7 times 1.2 times 10 to the 6th times 10 to the 8th. Take any calculator and multiply 2.7 times 1.2 to get 3.24. Now, to multiply powers having the same base, I keep the base 10 and add the exponents. So we keep the base, add the exponents. 6 plus 8 is 14. So multiplying these two very large numbers, I get 3.24 times 10 to the 14th. Now if you wanted to convert it back to decimal notation, then you can move your decimal 14 places to the right. When numbers get this large, I suggest you leave it in scientific notation and not try to convert it back to decimal. Let's look at another example. Let's evaluate 2,800 divided by 5 10,000ths, or 2,800 divided by 0.0005. The first thing we want to do is to write them in scientific notation. 2,800 is a large number, so the exponent is going to be positive. In order to get the decimal in the right position, I needed to move my decimal 1, 2, 3 places. So it's 2.8 times 10 to the third. 5 10,000ths is a small number, so the exponent is going to be negative. In order to get the decimal in the correct position, I need to move it 1, 2, 3, 4 places. So I have 2.8 times 10 to the third divided by 5 times 10 to the negative 4. Now you can take your calculator and do 2.8 divided by 5, and you'll get 0.56. And remember that to divide powers having the same base, I keep the base and subtract the exponents. So I keep the base 10, I subtract the exponents. Exponent 3, the top exponent, minus the bottom exponent. 3 subtract a negative 4. Or I get 5600ths times 10 to the 7th. 3 subtract a negative 4 is the same as 3 plus 4, which is 7. Be very careful with your negative exponents. This is an answer, but it's not in decimal notation and it's not in scientific notation. I need to convert it to pure scientific notation. To get it to pure scientific notation, I need to multiply this part by 10. I need to move my decimal one place to the right. So I need to multiply this part by 10. In order to keep everything equal, I would need to divide the second part by 10. So it would be 5.6 times 10 to the 6th. Or looking at it another way, this tells me to move my decimal 7 places to the right. So if I move it over 7 places, that would give me well, it wouldn't be a point if I'm moving it, so it would be 5, 6, and then I need 5 zeros. 1, 2, 3, 4, 5 zeros. So I've moved it 1, 2, 3, 4, 5, 6, 7 places. Now to get it in scientific notation, I need to move the decimal back to there, so I'd have to move it back 1, 2, 3, 4, 5, 6 places. So in scientific notation, it's 5.6 times 10 to the 6th.